What's up guys? As a second part in this video I'm gonna show you how to simplify the conversion of a region under 5 certain mapping function. Okay, let's move on. Consider mapping of w equals e to the z. Its equivalent in Euler form is w equals e to the x plus iy. Then we can separate this e to the x, e to the iy. Okay. As a conclusion, we will have this. Then rho equals e to the x and phi equals y. This is how we do it. Oh, there is another way to write this down in u and v. We will draw a graph look like this. This is x, y. This is our point. This is our point. Under mapping of w equals e to the z, our region for w this is our radius of e to the x, and this is phi or v. This is our angle. Okay, as a conclusion, u is equal to e to the x cosine phi or phi cosine phi e to the x in cosine times cosine y. V is equal e to the x sine phi or e to the x sine y. This is the definition of cosine and sine. This is cosine, this is sine. Okay, as an example, I brought you a line, this orange line, which is between -2 and 2, and height as much as pi over 4. We want to see what will become this simple line in under e to the z mapping function. Okay, just simply you should ask yourself what has happened to the x, it will happen to the y also. X is between -1 and 2. In Euler form, it is rho, and between e to the -1 and e to the 2. It's just a substitution. And we substitute our x in this formula. And y is equal to pi over 4. Then phi is pi over 4. We draw another graph in the converted region. This is 1 over e, and this is e to the 2. We firstly draw the angle. It's pi over 4. It is in the middle of the first region in polar coordinate. This is the radius of, I show you with another color. It is the radius of E1 over E. It is lower than 1. 1 is here, and 1 over E, as E is 2.77, it's lowered. And another radius is e to the 2. It's bigger than 1, somewhere like this. This is our converted region. I again show it with orange color. This simple line converted to this. E to the 2. For another example, I brought you this vertical line. You should ask yourself what has happened to the x and y. It will happen for the rest of it. X is a constant number 2. In this example, y is changing. It has a boundary of minus pi over 6 and pi over 4. We draw the converted region. X is equal to 2 and rho will be e to the 2. It's a constant curve, and y is equal to the y phi minus pi over 6 and pi over 4. Because our radius is constant, we firstly draw a radius of e to the 2. This is 1. E to the 2 is approximately equals to 7.3. It is e to the 2. We draw a curve as much as this, and pi is equal to minus pi over 6 and pi over 4. This is pi over 4. This is pi over 6. And this is pi over 4. That's it. We clean this out and we got our converted region. The green one is the converted line of this vertical line. Converted line is the green one. Next mapping that I want to talk about is vice versa, the previous one. It's w equals natural logarithm of z, and we can call this a function as it is limited to 2 pi or minus pi or minus pi and pi, or 0 to the 2 pi. I write this down. Theta is limited to minus pi and pi. We open it up like this. W equals natural logarithm of r plus I theta. This is how we do it. And as a conclusion, u equals natural logarithm of r and v is theta. In the preceding courses, I will call this ln as natural logarithm. As an example, I brought you this graph. It's a region. It's this region. I wanna find out what it will become under natural logarithm of z mapping function. We just cut it out in smaller pieces. This pink color line. Just write down the characteristic. Its radius is between e to the minus 1 or 1 over e and e to the 2, and its theta is changing from minus pi over 6 and pi over 4. That's it. To find out the pink color, I use the light blue. Theta is, we see that we should find out the u and v. We got a natural logarithm of each one. E to the ln of e to the minus 1 and ln of e to the 2, then we have minus 1 and 2. And v equals minus 1, pi over 6 and pi over 4. Pi over 4. We should draw this and these lines. U is changing from minus 1 and 2. Axis, this is u axis, and this is v. Minus 1 and 2. And v is changing from minus pi over 6 and pi over 4. The line that we are chasing is this line. That pink line became this light blue line. And for the orange curvature, we write down like this. R is a constant of e to the 2, but the angle is changing. Theta is changing from minus pi over 6 and pi over 4. Okay, we got an ln. U is ln of e to the 2. It becomes 2. And v pi over 6 and pi over 4. And this is the green line is the converted radius of e to the 2. That's it. Our next mapping function is called Joukowsky mapping function. it is like look like this, and if we write down in Euler form, we will have r e to the I theta plus 1 over r e to the minus I theta. Okay. Then in the polar form, we will have r times cosine theta plus I sine theta plus, I write it down this here, we had 1 over r cosine theta plus I sine minus theta. Its equivalent will be minus I times sine theta. It sends out the minus to out, the sine operator. If we wrap it up, then we will have u and v. In these forms, we will have u and v, the imaginary part and the real part. U is r plus 1 over r cosine theta, and v equals r minus 1 over r plus sine theta. As an example, I draw a unicircle with radius of 1. I mean, it has a radius of 1, and we want to find out the circle with bigger than radius of 1, what will become under Joukowsky mapping function. The radius is bigger than 1. Everything could be possible. Is bigger than 1. Take a guess. Pause this video and take an example. Simply put the r equal to 1 or everything in it, and after that play the video and find out. Okay, I hope you have find out the answer. The answer is becomes oval with the focuses of -2 and 2. This oval or elliptic with focuses of 2 and -2. Another thing that maybe we should consider is a unicircle. What will become a unicircle if we put r equal to 1? We should write down like this: u equals 1 plus 1 over 1 is 2 cosine theta, and v equals 1 minus 1 is 0. It's a single line between -2 and 2. Did you see? That is very easy. The blue circle became a single line between -2 and 2. As a second example, I brought you this beautiful area or surface, whatever you call it. It's very beautiful because I think that you will understand it very soon. The outer surface of the unicircle on the region of 1 and 2 of the Cartesian coordinate will become what? Is a question for us under Joukowsky mapping function. W equals z plus 1 over z. It's very amazing if you find out. This picture doesn't remember you of something. It's a sun. It's sun rays. If the sun sets, it will become what? C. we just see the ocean here. That's it. Will become C, and I think that's beautiful. For the eighth mapping function that I've chosen is W equals sine Z. We simply open it up like this. W equals sine x plus iy. And let me get this out in the open and simply write u and v straightforward. U is sine x hyperbolic cosine of y, and v is equal to cosine x hyperbolic sine of y. Maybe you can memorize this, it's very helpful in future. Okay, as an example, we want to find out this region, what will become under the sine mapping function. Okay, I draw another graph. This is u and v. Under sine mapping, it becomes bigger in a space, like an expansion, you know, look like this. It expands the surface from 0 to pi over 2, become from 0 to infinity. That's it. And this is the same direction. We will have another example of cosine that I'll tell you. Okay, if it was here, our region was from the minus pi over 2 to 0. What's your guess? It will be this region. It expands to this region, to minus infinity. This is how we do. Very good. I hope you are one of the guys that combine the last one that I'm telling. The last mapping function is cosine z. We can open it up like this. W equals cosine x plus iy. And we can be straightforward like this. Cosine x hyperbolic cosine y, and v equals minus sine, minus sine, it's new, minus sine x and hyperbolic sine y. That's it, and wait for an example. That's fine. For an example, I brought you this region. We want to find out under cosine z, what's the output, the converted region. We draw the graph. This is u, this is v, and it expands like a cross. It's a cross expansion. This region will come this way, and this blue, light blue region will come this way. I call it a cross expansion. That's the answer. And I have a question for you also. If it was a region was like there, the down there, the down in negative area, I mean this way. This was the orangey, and this was the green. What is the output? If you wanna think, pause this video and think. It's a cross expansion, okay? This region will become here, will move here, this will move here. This is the green new region and the orange region. Okay, as an ending, I hope you enjoyed this video and make sure to subscribe to my YouTube channel right now. Please click that subscribe button below this video. It's free and use this for your college life and your university life.